Okay, good afternoon. Today we will see machine design to subject. First of all, I will introduce myself. I, Dr. Sachin Sonone, working as associate professor in Department of Mechanical Engineering. I have 18 years of teaching experience. In that 2 years, I worked as head of the department. Now, this subject already I have taught 5 to 6 times. Now, this is the maybe 8th time I am teaching this subject. Therefore, first of all, we'll see now. First of all, we'll see vision, mission, PEOs and POs of this subject. Therefore, first of all, we'll see vision, mission of the institute and the department. Now, why first of all we have to study vision, mission of the college and department? Because first of all, vision is defined by the institute. That is where the institute will be, or what is the objective of the institute, what it would like to become in near future. Then mission is nothing but plan to achieve that vision, or mission is nothing but different practices, processes, so that our vision would be achieved. Then vision, mission, afterwards that PEOs, program educational objectives, are defined. Program means our program is mechanical engineering. Then afterwards, program outcomes are defined. Program outcomes means what? After 4 years of graduation, the students should have the different skills. That program outcomes also we'll see. Then these program outcomes are further disintegrated into different course outcomes. Course means subjects. That is, by studying various subjects from first year to final year, we are going to achieve that 12 program outcomes. And again, whatever COs are there, that COs are further divided into unit outcomes. Unit outcomes is what? You are knowing in particular subject, maybe in machine design 2 or heat transfer, what the different subjects are there. IUR, 6 to 8 chapters are there. Therefore, by learning each and every chapter, we are going to study different, or there will be a specific outcome for each and every chapter. That is known as unit outcome. Therefore, when all the unit outcomes will get combined, we will get course outcomes. Now, some subjects are having practicals also. Therefore, practical outcomes are also there. That is, suppose 6 to 8 practicals are there. Therefore, after performing that 6 to 8 practicals, for each practical, different practical outcome will be there. Now we are knowing that in practical outcome, that is through practical, skill is developed. Knowledge is also we are getting, but what is the advantage of practical? It is a skill development. That is the importance of practical. Now, therefore, like this vision, mission, POs, CO, unit outcome, practical outcome, like this it is there. Then we can say that after 4 years of graduation, student has achieved these program outcomes, or the vision of the institute is achieved. Therefore, first of all, we'll see vision and mission of the institute and department. To be national, first of all, vision of the institute, mission of the institute I will read, then vision of department and mission of department. Vision: to be nationally recognized among the best institutes in India for excellence in technical education. Mission: to impart value-added technical education through ambience of academic excellence, research, and life skills by inculcating personal touch and respect in relationship amongst the stakeholders. Now, departmental vision: to be nationally recognized for excellence in education geared with research in the field of mechanical engineering. Mission: to impart value-added education by creating ambience of academic excellence and research, along with participation in product development by inculcating personal touch and mutual respect. Now, program educational objectives. Whatever I have told, we are following same sequence only: vision, mission, POs. Therefore, the Department of Mechanical Engineering has its POs to produce graduates who first function successfully in professional environment by demonstrating technical expertise, to provide holistic solutions for complex and emerging problems in the field of design engineering, heat power, renewable engineering, renewable energy or renewable engineering, same case, automation, industrial engineering, manufacturing, and related management with consideration of safety, sustainability, economic feasibility, and environmental impact related issues. Second, PO: demonstrate strong leadership and communication skills and ability to function effectively as an individual as well as part of a team. Third, engage in enrichment of knowledge and skills through lifelong learning to evolve innovative solutions in mechanical engineering. Fourth, demonstrate a sense of moral and ethical values in their career. Now we will see program outcomes. Program outcomes are defined by NBA or National Board of Accreditation. It is an autonomous body to accredit various institutes. If our institute or any institute is NBA accredited, then we can say that that institute satisfies all the stakeholders' expectations. Which are the stakeholders? First is alumni, second is students, current students, then their parents, then society, then industry. These are known as the stakeholders. Therefore, whatever the expectations of all the stakeholders are there, that institute satisfies the different stakeholders. Therefore, program outcomes are the statements that describe what students are expected to know and be able to do upon graduating from the program. These relate to the skills, knowledge, attitude, and behavior that students acquire through the program. Therefore, whatever 12 POs are there, that 12 POs are divided into these 4 categories: skills, knowledge, attitude, behavior. These 4 categories are there. Therefore, engineering graduates will be able to first, they should have engineering knowledge. Therefore, these are the keywords, engineering knowledge. Therefore, in the engineering knowledge, what they are expected to do? Apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. Then second PO, problem analysis. Identify, formulate, review research literature, and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences. Third, design or development of solutions. Design solutions for complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for the public health and safety and the cultural, societal, and environmental considerations. Fourth, conduct investigations of complex problems. Use research-based knowledge and research methods, including design of experiments, analysis and interpretation of data, and synthesis of the information to provide valid conclusions. Fifth, modern tool usage. Create, select, and apply appropriate techniques, resources, and modern engineering and IT tools, including prediction and modeling to complex engineering activities with an understanding of the limitations. Apply. Sixth is the engineer and society. Apply reasoning informed by the contextual knowledge to assess societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to the professional engineering practice. Now, seventh is environment and sustainability. Understand the impact of professional engineering solutions in societal and environmental contexts and demonstrate the knowledge of and need for sustainable development. Eighth is ethics. Apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. Ninth, individual and teamwork. Function effectively as an individual and as a member or leader in diverse teams and in multidisciplinary settings. 10th, communication. Communicate effectively on complex engineering activities with the engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. 11, project management and finance. Demonstrate knowledge and understanding of the engineering and management principles and apply these to one's own work as a member and leader in a team to manage projects and in multidisciplinary environments. And 12th, that is lifelong learning. Recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. Therefore, these are the 12 POs. These 12 POs are also known as graduate attributes. Graduate attributes means graduate characteristics. That is, any engineer, let it be from any branch or any program. We'll say program because program is the appropriate word. From any program, if that engineer will pass out, that engineer must have these 12 characteristics or 12 attributes or 12 outcomes. Then and then we can say that that institute is providing quality education to the students. Now, since our institute is NP accredited, that is our mechanical engineering program is can be accredited. Therefore, we can say that in our mechanical engineering department, quality education is delivered to the students. Now, we will see the subject. First is its code, course code ME321. What is the meaning of ME321? ME means mechanical engineering, 3 means third year, 2 means second semester, and in 1 means in second semester first subject is machine design 2. It's like this nomenclature is there. ME321 machine design 2. Lectures 3 hours per week, practicals 2 hours per week, internal continuous assessment, that is term work 25 marks, ISE means in semester evaluation 30 marks, and end semester examination, that is your final theory examination of university is 70 marks. Now remember that all the restrictions, they have been removed by the government. Therefore, from this semester onwards, your exam will be offline exam. And for this subject, you require calculator also. That is, for 2 to 3 lectures, there will be only theory. But after that theory, I am going to take problems and you have to solve the problems. Therefore, wherever you are, you may be at home or wherever you are sitting, remember that for machine design 2, you require separate notebook, you require pen, you will require calculator also to solve the problems, because question paper consists of all the problems, because already that 14 marks objective questions are there. Therefore remaining only 56 marks. Therefore, in 56 marks, they are going to ask all the problems. Theory, if they will ask theory, they will ask derivation. If they will ask theory, they will ask derivation only. Therefore, this subject is mathematical, or we can say that analytical subject. Now, I will read the syllabus. First is course introduction. This course seeks to provide an introduction to design of various machine elements and discusses various design procedures, requirements, and design methods. It introduces the design procedure for various types of gears like spur gears, helical gears, bevel gears, and worm gears, along with the introduction to AGMA standard. Further, a content explains in detail the significance of pressure vessels, design procedure, and introduction to various standards used for pressure vessels. The different types of bearings, their significance, and the selection of the rolling contact bearings from manufacturer's catalog, and the design considerations of sliding contact bearing are also included in the course content. Course prerequisite: students shall have knowledge of function of different machine elements, such as different types of gears, bearings, shafts, keys, etc. A sound background of mechanics of material and fundamentals of design of machine elements is essential for successful completion of this course. Therefore, see that whatever these gears are there, spur gear, bevel gear, helical gear, worm gear, then pressure vessels are there, then different bearings are there, sliding contact bearing, rolling contact bearing. Already all the whatever these parts are there, gears, bearings, or pressure vessels, you have drawn freehand sketches, or you have studied all the drawings of this subject in machine drawing subject. Machine drawing and CAD, that subject was there to you. Therefore, in that subject, you have studied all the drawings. of the different gears, conventions of gears you have seen. Then you have studied convention of bearing also, pressure vessel also. Therefore, you have drawn all the gears in convention, that first chapter of machine drawing subject. Therefore, now again in the first semester only you have studied that mechanics of material, or you can say that strength of material. In that you have found out different stresses, strains, shear stress, torsional stress, bending stress, whatever it is, tensile stress, compressive stress. You have studied different chapters. And in machine design first also, you have studied that knuckle joint, then shaft, keys, coupling, fluctuating loads. These chapters you have studied. Therefore, knowledge of all these three subjects will be useful to us while studying this subject, that is machine design 2. Now we will say course outcomes. Therefore, what is meant by course? Course means subject. Therefore, at the end of this course or after studying this subject, the student will be able to. Now, first course outcome is design the spur and helical gears under different loading conditions. Now, since it indicates design, therefore it is Bloom's level 3, related topic 1. Second CO, apply the different equations for design of thin and thick cylinders. Here double word is there, design. Bloom's level 3, related topic 2nd. Then third CO, explain the statistical considerations in design. It also consists of problems. Therefore, this is BL3, third Bloom's level, related topic 3. Then fourth CO, design the bevel gears under different loading conditions, BL3, related topic 4. Fifth CO, calculate the dimensions of worm gears under different loading conditions, BL3, related topic 5. And CO number 6, select the bearing from the manufacturer's catalog, BL3, related topic number 6. Therefore, these are your course outcomes. That is, after studying this whole or this complete subject, you will be having these different skills. Now, again, these are the course outcomes in the syllabus. Now, I will read the syllabus. Syllabus is divided into section 1 and section 2. In section 1, 3 units are there. In section 2, 3 units are there. Now, first unit is unit 1, spur and helical gears. Number of lectures 11. In that, first of all, we will see unit content of spur gear, design considerations of gears, gear materials, types of gear tooth failures, hunting tooth, gear tooth loads, minimum number of teeth, face width, Lewis equation, Spott's equation, Buckingham's equation, introductory treatment, gear design for maximum power transmission, then introduction to AGMA code. Then helical gear, virtual number of teeth, force analysis, beam and wear strength, effective load on gear tooth. Then unit 2nd, pressure vessel, number of lectures 6. Its unit content is thin cylinders, types of stresses, design of thin cylinders. It is a numerical treatment. Then thick cylinders, types of stresses, failure criteria. In failure criteria, 3 criteria are there: Lamage equation, Claverino's equation, Birri's equation. It will consist of numerical problems. Then next is introduction to compound cylinders, auto fittage, unfired pressure vessels code, types of end closures. Now, for the types of end closures, there is no numerical treatment. Next is effect of opening and nozzle in shell and covers. It is having numerical treatment. And last point of this chapter is introduction to ASME codes for design of pressure vessels, introductory treatment. Now unit 3, statistical considerations in design. Number of lectures 3, unit content, frequency distribution, probability distribution, normal curve, design and natural tolerances. Now section second consists of 3 chapters. In that, unit 4 is bevel gear, number of lectures 5. Its content is terminology and geometrical relation, force analysis, mounting of bevel gears, beam strength and wear strength, dynamic tooth load. Unit 5, worm gear, number of lectures 5. Unit content, terminology and geometrical relations, materials, standard dimensions and recommendations of worm gearing, force analysis of worm drive, friction in worm gear, efficiency and design criteria of worm drive as per IS 7443/1974, load rating of worm drive, strength and wear rating of worm gear, thermal considerations in worm drive. Now, next unit 6 is rolling contact and sliding contact bearings. Number of lectures 10. Now these one chapter is divided into 2 chapters. First is rolling contact bearing types. What are different bearing types? Then static and dynamic load capacities, Strybeck's equation, equivalent bearing load, load life relationship, bearing life, load factor, selection of bearing from manufacturer's catalog, ball and roller bearing, design for variable load and speed, bearings with probability of survival other than 90%, lubrication and mountings, dismounting and preloading of bearings. Now, sliding contact bearings, bearing material and their properties, bearing types and their construction details, hydrodynamic lubrication, that is performance analysis of hydrodynamic bearing by Raimondi and Boyd method. And last point is introduction to hydrostatic bearings, introductory treatment. Therefore, this is your syllabus. Now, ICA means your term work, internal continuous assessment, design and drawing using design data book. First is gearbox or pressure vessel. We are going to study pressure vessel. We are not going to study gearbox for our division. For other division, I am not knowing, but pressure vessel I am going to take. It is very simple. Only drawing is complicated. Therefore, we will see the drawing. I will circulate the drawings to you. You can draw the drawings on sheet. Then ICA also consists of B part, that is assignments on minimum 5. First is spur gear, second helical gears, third bevel gear, fourth worm gear, fifth rolling and sliding contact bearings, sixth pressure vessels, seventh design and natural tolerances, and eighth is study of different codes. Therefore, this is your term work part. Now, when this spur gear chapter will get completed, at that time in one lecture, we will take assignment on spur gear. That is, we will solve 2 to 3 problems on spur gear. That will be your assignment. At the end of helical gear, similarly, I will take 1 or 2 problems. You have to solve that 1 or 2 problems, and that will be your term work. Same case for bevel gear, worm gear, rolling contact, and sliding contact bearing. Therefore, your assignment will get completed when? During our theory course itself. only that this design and drawing of pressure vessel, that I will require minimum 2 to 3 practicals, means 4 to 6 hours it will require. Only you have to write down the calculations and drawings I will circulate. You can draw the drawings on the sheet. Whatever drawings it is there, you have to draw the drawings as it is. Now textbooks, design of machine elements by V.B. Bandari, machine design by Robert L. Norton, PhD design data book. Reference books, design of machine elements by J. Shigley, design of pressure vessel by Harvey, machine design by Hall, Polovenko, Shams, outline series, and fourth is introduction to tribology by Muzumdar. Therefore, these are the reference books, 4 reference books, 3 textbooks. Now we will see what is meant by machine design. Therefore, what is the importance of machine design for engineers? What is machine design? Therefore, what is meant by machine design? It is nothing but creation of new and better machines and improving existing ones so that it is economical in the cost of production and operation. Therefore, machine design means what? Design itself. The word design. What is the word? What is the meaning of the word design? Design means to create new things or to modify existing things. Therefore, same case is there. Creation of new and better machines and or improving existing ones so that it is economical in the cost of production and operation. Now always remember, whenever we are going to design the things or whenever we are going to create new things, it must be economical. Otherwise, no one will purchase your product. Now, in earlier case, you are knowing that refrigerators or fridge were there. They were consuming more electricity. Is it correct? After some time, you can say that a 3-star refrigerator, 5-star refrigerator, 4-star refrigerator came. Therefore, what the star indicates? Star indicates that if maximum stars are there, therefore that refrigerator will consume less electricity. Means like this, new design has been created, a new product has been created so that it is economical. We have to consider, always remember, for each and every aspect in our life, we have to consider economy or money part. Then and then we will survive. Otherwise, you are knowing the conditions of different businessmen. I will not take name. Businessman, recently one businessman is bankrupted. You are knowing that name. Therefore, every time we have to consider economical aspect. Now you are knowing that whenever we are running our home, our fathers and mother, how they are running our home, every time they are considering economical aspects, that don't waste money here. Our father and mother, sometimes they are not eating, but they are providing money to you. Therefore, this is also economical aspect. Or they are not going here and there, but they are giving money to you for your industrial visit or wherever you want to go. Means like this economical aspect is there in each and everyone's life. Without considering economical aspect, no one can function in this world. Means at least human beings also. We are talking about human beings only. Therefore, that economical aspect we have to take into consideration. Now, how a design is born? First is creation. Design means what? Creation of new things. Therefore, we'll see this. How the design is born, this diagram is there. First of all, we have to see market survey, or we have to do the market survey of the different products, whether that product is available in the market or whether that another design modification is required in that product. Therefore, that market analysis we have to take into account. Then aesthetic and ergonomic concept. Aesthetic means what? How that product looks like. You are knowing our pen or maybe mobile phone, it is an aesthetic nature. So that after seeing that thing, everyone wants to purchase that pen or mobile or anyway, or whatever, anywhere. You can take example of two-wheeler, you can take example of four-wheeler. Aesthetic means what? Look. What is our look or that face of that product? Then next aspect is ease of handling. Third aspect is safety. Sorry, fourth aspect is safety. Fifth aspect is economical. And next aspect is recyclability. And all these aspects will come in terms of, in one word, that is marketability of the product. That is which characteristics are there in the product so that it will stand in the market. Next is availability of funds. You are knowing for each and everything we require money. Funds means money only. Therefore, without funds, we can't survive or we can't do the new things without funds. Then availability of material. Now you are knowing material cost for whatever products are there. In that 60 to 70% material cost is there. 60 to 70% material cost is there. Therefore, availability of material, suitably or economical material we have to take into consideration. Then manufacturing resources. What are different resources are there? Which resources are there? 5 M's are there. Man, machine, material, methods, money. Man, machine, material, methods, and money. 5 M's are there. These are known as resources. Then here materials, same conditions are there. Then we have to take into account size of that product also. What is the size of the product? Now all these 4 aspects, marketability, availability of funds, material available, and manufacturing resources. By taking these 4 aspects into consideration, we can prepare model or rough idea. Then once we'll prepare that model, here we have to take into account its size, material, then we have to do the analysis. You are knowing either software analysis, numerical analysis, whatever it is. On that model, we have to find out different forces and stresses or strains, or we have to do the failure analysis of the product. And at that time, we have to see the requirement. So requirement is market survey. These 2 words are same. Synonyms is samanarthi shabda, requirement or market survey. And by considering all these aspects, we can create a new product. Therefore, to design the new product or to create a new product, we have to take into account all these things. Now, what is the basic knowledge required for machine design? First is mathematics. Second is engineering mechanics. Third is strength of materials. Now this engineering mechanics and strength of materials, there are different names to this: mechanics of materials, mechanics of machines, then fluid mechanics and thermodynamics. Then we must know workshop processes. Workshop processes you have studied: casting, welding, then different operations carried out on lathe machine, different operations are carried out on milling machine, shaping machine, slotting machines, drilling machine. Therefore, these are known as workshop processes: casting, welding, or different these machining processes. Then we require knowledge of engineering drawing. Engineering drawing means you have studied this subject in first year. Then we know the another part, that is computing analysis. Computing software means what? Analysis software. That means finite element analysis, computational fluid dynamics, etc. Therefore, next point is important considerations in machine design. First is type of load and stresses caused by the load. In that, first of all, dead loads. Dead load means what? What is meant by dead load? Dead load means this weight of bench, weight of table, weight of computer, weight of slab, weight of beam, weight of wall. The things which are not moving, they are known as dead load. Next is live load. Live load means what? Weight of human being. Humans are moving here and there in the college, therefore that weights, that live load is varying. Another example of live load is but wind load. Wind load, you are knowing winds are flowing, therefore these loads are varying. Therefore, these are live loads are also known as fluctuating loads. Fluctuating loads means what? The loads which are increasing also and which are decreasing also. Means the loads which are increasing and decreasing, that loads are known as fluctuating loads. Live loads are classified in steady loads and variable loads. Then next is shock loads. Shock load means it is applied suddenly. Where you are getting shock load? Where we are getting shock load. Now you are knowing that in whenever we are lifting anything with the help of crane, and then that crane suddenly drops that thing on the earth or on the ground. Therefore, that load is nothing but shock load. And because of that shock load, that potential energy gets converted into kinetic energy when that load is dropped. Therefore, that is known as shock load. Or where we are experiencing shock loads, I think all of you are driving 2-wheelers and 4-wheelers. Therefore, the shock absorbers are there. Shock absorbers are absorbing the shock loads. Where you are getting shock loads? Because of ditch. Ditch means in Marathi it is called as खड्डा. जेव्हा तुमची गाडी खड्ड्यामधून जाते तेव्हा असं शॉक बसतो खाली. And that shock is absorbed by the 2 shock absorbers on the back side and front shock absorber on the front side. Therefore, these shock loads are absorbed by these shock absorbers. Always remember. Then next is impact loads applied with some velocity. Impact loads applied with some velocity means what? You are knowing, suppose one bar is there, and on that bar at the end some disk is there, and suppose you want to put many disks in that bar, therefore you are putting one the disk, hollow disk, and you are inserting in that bar, and that disk is going to move slowly, and it will again stacks म्हणजे काय? Stacking. What is stacking? एकावर एक रचणे. कुठली गोष्ट एकावर एक रचतो, ज्यावेळेस त्या डिस्क आपण हळूहळू सोडतो खाली, त्यावेळेस डिस्क एकमेकावरती रचत जाणार. That is nothing but impact loads applied with some velocity, because that disks are moving with some velocity. Shock load means suddenly load. But impact loads are 3 types of impact load: gradual, impact, and what is there? 3 types of impact load. You have studied that impact load chapter in strength of material. Therefore, these are the different loads. Now these are the different stresses and strains. Stress and strain, that is tensile stress, compressive stress, shear stress, thermal stress. You have studied these chapters also. Then torsional stress due to torque or moment, bending stress. Now, important considerations in machine design. First is kinematics of the machine. It consists of study of motion of the parts, In that, find the simplest arrangement that would give the most efficient motion that is required. Next is selection of materials. Knowledge of the properties of the materials and their behavior under working conditions is required. Strength, hardness, durability, flexibility, weight, resistance to heat and corrosion, electrical conductivity, machinability, etc. Now, first is selection of materials. In that, materials are classified into metals and non-metals. Non-metals means plastic. Metals are further classified into ferrous and non-ferrous metals. Ferrous means which contains iron, and non-ferrous means which does not contain iron. Iron and non-ferrous metals means nickel alloys, titanium alloys, gold, silver. These are non-ferrous materials. Then we have to take into account their physical properties. Physical property means what? Density, melting point, electrical and thermal conductivities. Mechanical properties. Which are mechanical properties? Tensile strength, ultimate tensile strength. Then Young's modulus. Strength. Strength means what? What is the meaning of the word strength? Strength means it is the resistance or strength resist externally applied loads without breaking or yielding. Strength is also known as resistance. Strength is also known as resistance. Then stiffness, resist deformation under stress. Elasticity, regain original shape once the force is removed. Plasticity, property which retains deformation required for forging, etc. Ductility, ability to be drawn into a wire by tensile force. Then brittleness, sudden breaking with minimum distortion. Toughness, resistance to the fracture due to high impact load. Creep, deformation under stress and high temperature. Fatigue, ability to withstand cyclic stresses. Hardness, resistance to wear, scratching, deformation, and machinability, etc. Now, next point is form and size of the parts. What is form? Form means shape and size of the parts. Therefore, use of I-beam or angle iron. The size will be determined by the forces or torques applied, stresses on the object, and the material used as such that failure means fracture or deformation would not occur. Now, general procedure in machine design. First is need or aim. We have to see whether need or that particular thing there is need in the market or not, or market survey. Recognize and specify the problem. Second is synthesis. Synthesis means what? Select the mechanism that would give the desired motion and form the basic model with a sketch, etc. Analysis of the forces, then material selection, then design of elements. Design of elements consists of determine the stresses and thereby the sizes of components. Sizes of components subjected to, ST means subjected to failure or deformation. Failure or deformation does not occur. This design of elements, they are interrelated with this material selection. That's why arrows are there. And modification. Modification means what? Modify sizes to ease construction and reduce overall cost. Then afterwards, detailed drawing is there. Assembly details you have studied. And that detailed drawing, it is went or it will go to the production for producing the different products or different shapes. Therefore, this is nothing but general procedure in machine design. I think today we'll stop here. Then we'll see this significance of design of components. We'll stop here.